Approaches for classifying farming systems. Farming systems with identical resource endowment and resource use are rare. Differences can be found, for example, in family size and the age of family members, land sizes and the number of livestock, financial and machinery capacities, or access to natural resources. When considering several farming systems simultaneously, an individual analysis and representation of each farming system is rarely possible due to capacity constraints. In such cases, the summarization of similar farming systems into groups is necessary. This summarization requires the classification of individual farming systems according to criteria that best address the research question. The possible classification criteria can be roughly divided according to the scale level on which they are measured. A classification based on a qualitative criterion clearly distinguishes the classes from each other. A farming system has a certain qualitative characteristic, or it does not. The advantage of the clear distinction between the classes is opposed by the disadvantage that no intermediate stages can be taken into account. A classification based on a quantitative criterion allows for the consideration of intermediate levels, but requires a decision on the location of the boundaries between the classes. The choice of the most appropriate class boundaries can be supported by statistical tools. The goal of a classification is to identify groups of farming systems that are as similar to each other as possible. At the same time, the classes should be sufficiently different to justify the division into classes at all. The classification based on the chosen criteria therefore requires two standards. The first is a measure of the similarity of farming systems, the second a measure of the difference of the classes. An adequate classification is therefore based on the selection of relevant classification criteria, and the choice of comprehensible standards for the similarity within a class and the differences between the classes. Decisive for the choice of classification methods is the question of whether one or more criteria should be used for classification. The use of just one criterion allows for the selection of methodically simpler standards for recognizing similarities and differences. In a sequential univariate classification, several classifications are conducted one after the other based on a single feature each time. Naturally, the number of cases per class decreases with each additional classification step. Low case numbers have the disadvantage that statistical indicators for the affected classes lose in meaning and precision. This applies to both averages and frequencies and their corresponding variability parameters. If individual criteria for describing the research question are insufficient and the class sizes become too small in a sequential univariate classification, methods of multivariate classification can serve as an alternative. Multivariate classification procedures allow for the simultaneous consideration of several classification criteria, but they use methodologically significantly more complex approaches and standards for measuring similarities and differences. One of the most commonly used multivariate methods is cluster analysis. The use of a cluster analysis is limited by the requirement for the same scale level of all considered classification criteria. A mix of quantitative and qualitative classification criteria is not possible.